Hello students, welcome to lecture 9 of online chemistry classes. We have completed chemical equilibrium with lots of questions and the various concepts. Now we'll start with the ionic equilibrium. Ionic equilibrium. In the ionic equilibrium, we have to start with the definition of the electrolyte and the non-electrolyte. What these electrolytes and non-electrolytes are? These are the substances. These are the substances, and we can classify them. In fact, Faraday has first classified. Michael Faraday has first classified these substances into two categories. One is called as electrolyte and another is called as non-electrolyte. So what we mean by electrolyte and non-electrolyte? We can say electrolyte are the substances which conducts electricity in aqueous or molten state. This is the definition. If a substance conducts electricity in aqueous means when we put it into water, or molten means when we melt the solid and it becomes liquid and it starts conducting electricity. Such substance we call it as the electrolyte. Non-electrolyte we say do not conduct electricity. Do not conduct electricity in aqueous or molten state. Now question is, why electrolyte conduct electricity? We said that ions are formed when we put that substance into water or when we melt them. Ions are formed. Ions are charged species, either positive or negative, and due to their charge formation they conduct the electricity. They migrate towards the oppositely charged electrode and electricity is conducted. But non-electrolyte, we say they do not form ions. Now if they do not form ions, then what they form? They form molecule. Means if you take glucose and put into water, it will remain as a glucose molecule in water. But same thing is not there for NaCl. If you take NaCl and put that into water, it gets separated into Na plus ions and Cl minus ions. So here ions are formed in case of electrolyte, whereas in non-electrolyte they do not form the ions. We'll see the example like HCl, sodium chloride, potassium nitrate. In here example we can say glucose, urea, cane sugar, or we can say sucrose. So Faraday said substances are of two types. One, when we put that substance into water or melt them, ions are formed, conduct electricity. Others, if we put them into water, do not form ions, do not conduct electricity, and they remain as a molecule into the water. So this is the way in which the substances can be classified. Now this electrolyte can be further classified into strong electrolyte and weak electrolyte. Now what is the difference between strong electrolyte and weak electrolyte? We can say strong electrolyte, it ionizes completely. Ionizes completely, almost completely. Whereas this ionizes feebly. Feebly means to small extent. Ionization is very low. We can say here degree of ionization, extent of ionization is very high, and here degree of ionization is very low. So this alpha, we call this degree of ionization, it nearly equals to 1. It means 100% molecules get ionized, and here alpha is less than 1 but greater than 0. Ionization is 0 for non-electron. Degree of ionization is 0 for non-electron. It is greater than that, but less than 1, because 1 is the degree of ionization of strong electrolyte. Now, what are the examples of strong electrolyte? We have to remember these examples, because just by looking into example we cannot say whether that electrolyte is strong or not. So examples of strong electrolyte. Examples of strong electrolyte are some strong acids like HCl, H2SO4, HNO3 and chloric acid, and strong bases like potassium hydroxide, sodium hydroxide, rubidium hydroxide, cesium hydroxide, and all type of salts like sodium chloride, potassium bromide, barium sulfate. These are the examples of strong electrolyte where degree of ionization is very high and they ionize almost completely. What are the examples of weak electrolyte? Weak acids. Now, which acids are weak? Formic acid, acetic acid or ethanoic acid, hydrogen cyanide, carbonic acid. And weak bases like aluminium hydroxide, ferric hydroxide, or we can add ammonia also. So these are the examples of weak electrolyte, and these are examples of strong electrolyte. By just looking into formula, we cannot identify which is strong and which is weak. So practice is needed. We first try to remember this, because this is the part which requires some memorization. Afterwards, not memorization is needed, because once acid is before you, you'll understand. Now, why they are strong and why they are weak? Their dissociation is greater here, and dissociation is smaller here. So, equilibrium constant for dissociation of strong electrolyte is higher, and equilibrium constant for weak electrolyte is lower. So, if we take a weak electrolyte, say Ba is a weak electrolyte. It ionizes to B plus and A minus in aqueous medium, and there is this reversible sign, means reaction can go in forward direction as well as reverse direction. And at equilibrium there are ions and there is unionized electrolyte, which is weak electrolyte. So that equilibrium we are interested in learning the ionic equilibrium. So this is for weak electrolyte, reversible sign. And we want to know what are the concentrations of product divided by reactant. We call this as equilibrium constant. What are the factors on which it depends? All these parameters of this equilibrium we have to learn in the ionic equilibrium. Now, before going into this ionic equilibrium, we have to learn few concepts which defines what we mean by acid and what we mean by base. So there are three concepts which are there in our syllabus. The first one we call it as Arrhenius concept. The next one is called as Bronsted-Lowry concept, and third is called as Lewis concept. So concept of acids and bases. The first one is the Arrhenius concept. According to this concept, we call those substances acid which gives hydrogen ion, H plus ion, which is nothing but proton, in aqueous solution, and base is a substance which gives hydroxyl ion, which is OH negative ion, in aqueous solution. For example, if you put HCl in water, it forms H plus and Cl minus ion. As it forms H plus ion, we call this as the acid. Very simple. Substance which gives H plus ions in aqueous solution are called as acid. If we take sodium hydroxide, it releases Na plus ion and the OH minus ion. As it gives hydroxyl ion, we call this type of substances as the base. So according to Arrhenius, if you want to know whether substance acid or base, very simple. Put that substance in water and see what type of ions it releases. If it releases H plus ion, we call that substance as acid. If it releases OH negative ion, we call that substance as a base. For many years, this concept was accepted, but there were two very important limitations of this concept. The first one, we cannot define acid or base in a non-aqueous solution. If solvent is other than water, the concept is unable to define substance whether it is acid or base. So you can say applicable only to aqueous solution, but there are many other solvents in which we need to put that substance, like alcohol, ammonia, ether, carbon disulfide. But this concept is no more applicable to that particular solvent. And one more limitation of this substance was, it could not explain acidic nature of CO2, SO2 and basic nature of ammonia, calcium oxide. These are the two limitations of this concept, that only aqueous medium is required, and there are many substances which are acidic but they could not give H plus ion. There is no H plus ion in CO2. There is no H plus ion in SO2. Still they are acid by their properties. And NH3 could not give OH negative ion. Calcium oxide could not give OH negative ion. Still it is base. Arrhenius could not explain this concept. And one more thing we have to remember, that this H plus ion is unstable because it has very high charge density. It has very high charge density. So how it gets stabilized? It combines with H2O and form H3O plus, which we call it as hydronium ion. The geometry of this hydronium ion is trigonal pyramid. Oxygen is in sp3 hybridized, just like ammonia. Like this. H3O plus. And we have to say that when we say H plus ion in aqueous medium, we should consider it as the hydronium ion, because that's how it exists in the solution. So this limitation has to be addressed because it's very serious limitation. So next concept, which try to remove the disadvantages of this substance, comes in picture, and it is called as Bronsted-Lowry concept. Second concept, Bronsted-Lowry concept. According to this concept, acid is a substance which gives proton, means H plus ion, not necessarily in aqueous solution. So this is more superior. Superior means it includes more acids, because that aqueous medium condition is no more valid for this. And base is that substance which accepts proton or H plus ion. Very simple definition Bronsted-Lowry has given. HCl, if it gives proton, then it is acid. And in H3, when accepts proton, it is base. Like that. So this definition removes that important condition, which was limitation in fact, that it should be an aqueous medium. It made more generalized sense. And instead, acid is a substance which gives proton, which donates proton, and bases are those substances which accepts the proton. In that way, define it. Now, according to this concept, which is the proton-based concept, we can say that in this concept, if we take the example like NH3 plus H2O, see what is the difference in previous concepts and this concept. NH3 aqueous, H2O liquid, NH4 plus and OH liquid. Now if we compare NH3 and NH4 plus, we can say that it accepts proton, and that's why ammonia is a base. And H2O and OH negative. What is the difference between H2O and OH negative? Only one H plus ion. So you can say it donates proton, and that's why it is an acid. So there is acid and base pair, which is at this is acid. If we compare this one as NH4 plus gives NH3, NH3 is base. If we compare NH4 plus as NH4 plus is becoming NH3, it means it is donating proton. That's why it is again acid. If this is base 1, this is acid 1. And compare the H2 and OH negative ion. OH negative ion to H2O. How it gets changed by accepting the proton. And proton acceptor is nothing but base. So we call this as acid 1 and base 1. How to identify it? We have to connect this NH3 and NH4 plus. That substance which is capable of giving proton is acid. That which has more H plus ion is acid. And that which is lacking H plus ion, because then only it accepts, is a base. Compare the another example. HCl aqueous plus H2O liquid, Cl negative plus H3O aqueous. Yes, now you can compare with this. We first connect these two, and we can say that there is one more H plus here and one Cl negative here, so this is capable of giving protons, which is acid 1, and Cl negative accepts proton and becomes HCl. That's why it is base 1. Compare these two. H3O plus is having more H plus ion than H2O. That's why it is acid 2. And this is base 2. We call these pairs as conjugate acid base pair. Now why do we call them as pair? Because there is difference of H plus ion into it. And what do we mean by conjugate? Conjugate is related. So there is related acid base pair according to this Bronsted-Lowry concept. So acid base pair that differs only by one proton is called as conjugate acid base pair. So acid base pair differs by one proton. Acid base pair. And the example is NH3, NH4 plus, H2O, OH negative, HCl, Cl negative, H2O, H3O plus. Now can you identify the acid and base into it? We'll make one question here, because this type of questions exactly asked in exam. So see what question I am writing here. Write the conjugate bases. Write the conjugate bases for the following Bronsted acids. For the following Bronsted acids. Bronsted acid, Bronsted base. How to convert this Bronsted acid to Bronsted base? Acid is that substance which donates proton. So either you write H plus in product site or take out proton from it and you get the conjugate base. For example, We have already written that question. HCl. Then HNO3. Then third one is HSO4. Negative. H2SO4. H2S. HF. And HCO3 negative. Take out one H plus ion from it and become Cl negative ion. Why I am writing negative? Because one positive charge is removed out from it. It contains one H plus ion and one Cl negative ion. That's why when proton is taken out, the substance has one negative charge on it. Take one H plus ion, it becomes NO3 negative. Take one H plus ion, already it is one negative, two negative. Take out H plus ion, HSO4 negative. Take out proton, HS negative. Take out proton, F negative. Take out proton, CO3 negative. So try to understand. We are removing one proton and we are getting. This is the Bronsted bases of their respective Bronsted acids. Reverse is also true. If Bronsted base we have and we add H plus ion, we get the Bronsted acid. So we'll take one more question. Write conjugate acids for following Bronsted bases. So Bronsted base, add H plus ion into it, and we get Bronsted acid. We'll take few examples here. Let's see how you can complete that. The first one is NH2 negative. Add one H plus, charge will be neutralized, and 2 hydrogen becomes 3 hydrogen. Next one is NH3. Add one H plus, no charge, now it becomes positive. Third one, OH negative. Add one H plus, there will be 2 hydrogen, H2O. This negative and this positive becomes neutral, no charge. H2O. Add one H plus, 2 becomes 3 hydrogen, and it is hydronium ion. Fifth one, C2H5OH. C2H5OH2 plus, we can write. And sixth one, HCO negative ion. Add H plus to it and become HCOH. So these are the few examples of conversion of acid to base. Acid, remove proton, base. Base, add proton, acid. Because there is only difference of proton between acid and base. Now there are some substances, we call them as amphoteric substances. Just like frog is an amphibian animal, means it can live on land as well as water. Here we have amphoteric substances. Amphoteric means which can act as acid as well as base. So we can say the amphoteric substances. For example, we'll make a column here. Species and conjugate acids. And the same substance, we can make conjugate base out of it. H2O. Next is HCO3 negative, HSO4 negative, NH3, HS negative. How to make acid? Add one H plus, H3O plus, add one H plus, H2CO3, add one H plus, H2SO4, add one H plus, NH4 plus, add one H plus, H2S. How to make base? Take out H plus, OH negative. Take out H plus from this one, CO3 2 negative. 1 H plus, SO4 minus 2. 1 H plus, NH2 and 1 negative charge. 1 H plus, S minus 2. So these species, we call them as amphoteric because we can form acid and base from them. They can act as acid, forms base, act as base, form acid. That's why we call them as ampho, means both nature they have, acidic nature as well as basic nature. So this is also one of the important concepts in the Bronsted concept. Now I will give you 5 or 4 reactions and you have to identify the acid 1, base 1, acid 2 and base 2 of those reactions, so that this part will be completely, all concepts will be covered. So I will write the reactions. Acetic acid is the COH aqueous, plus H2O liquid reversibly gives H3O plus aqueous plus CH3COO negative, like this, aqueous. Next is H2O plus CO3 2 negative, carbonate ion, hydrogen carbonate, or we call it as bicarbonate, plus OH negative. HCO3 negative, aqueous, plus NH3 aqueous, and we get CO3 minus 2 and NH4 plus. HCl aqueous plus HCO3 aqueous H2CO3 aqueous plus Cl negative aqueous. So I have to identify which one is acid, which one is base. Acid 1, base 1, acid 2 and base 2 out of this. So if you consider this, we have to connect this two. And why to connect this two? Because there is difference of H plus ion in them. H2O is to be connected with OH negative ion. And CO3 minus 2 is to be connected with HCO3 negative ion. HCO3 is to be connected with CO3 negative 2 and NH3 to the NH4 plus because that differs by this proton. HCl with the Cl negative and HCO3 negative with the H2CO3. And then we have to identify which one is acid 1 and which one is acid 2. So CH3COH and CH3CO negative, which is capable of donating proton, of course CH3COH. So it is acid 1 and it becomes base 1. H3O plus and H2O, which has donated proton, H3O has donated proton to become H2O. So it is acid 2 and this is base 2. H2O and OH negative ion. This is acid 1. This is base 1. HCO3 negative ion. CO3 2 negative ion. This is acid 2 and base 2. H3O plus negative ion and CO3 2 negative ion. Acid 1. Base 1. NH4 plus and NH3. Acid 2. Base 2. HCl and Cl negative. Acid 1. Base 1. H2CO3 and HCO3 negative. Acid 2. And this is base 2. In that way, we can identify. Yes, see how I have written this acid 1, base 1, acid 2 and base 2. If acid 1 is at reactant site, acid 2 should be at, base 1 should be at product site. And if acid 2 is at product site, base 2 should be at reactant site. In this way, both acid and bases cannot appear at the same site. 1, 2, 1, 2, 1, 2, 1, 2, like that. Because acid 1 gives base 1 and base 2 gives acid 2. In that way, all this sequence comes. Now, one last thing we have to mention here, that if HCl is a strong acid, it gives H plus ion, proton, Cl negative ion. This is conjugate base. As acid is strong, conjugate base is weak. So strong acid forms weak conjugate base. Consider this NH3, which is a weak base, accept protons and becomes NH4 plus. As it is weak base, it is strong conjugate acid. So if base is weak, its conjugate acid is strong. And if acid is strong, its conjugate base is weak. In that way, they are related. So this is last point. So we should know what we mean by acid and base by Bronsted theory. What we mean by conjugate acid base pair. How to convert acid to conjugate base and base to conjugate acid. How to identify conjugate acid base pairs. Amphoteric species and this relation. If acid is strong, conjugate base is weak. If base is weak, its conjugate acid is strong. These are the 3 points which we have to learn in the Bronsted law concept. Last concept regarding acid and base is the Lewis concept. We have to apply it in so many different topics. Let's see how we can define the Lewis acid and Lewis base. So we can say that Lewis acid is a substance which can accept electron pair. Third is Lewis concept. Acid and base. How we define it? The first point here says that substance which can accept electron pair is called as acid, and substance which can donate electron pair is called as base. This is the definition. Now most important thing is example, because so many examples we can put here. The first one is molecules having an atom. Molecules having an atom with incomplete octet. You have seen the examples of incomplete octet in chemical bonding. AlCl3, aluminum has only 6 electrons around it because there are only 3 chlorine. And BF3, which also has only 6 electrons. First example. The another is simple cations. Like H plus, Ag plus, this also comes into this category. Third one is molecules in which central atom has vacant orbital. Molecules in which central atom has vacant orbitals. Example, SiCl4 which has vacant d orbital, or SnCl4 which also has vacant d orbital. And molecules having multiple bonds. Last one. Molecules having multiple bonds. Example, CO2 and SO2. And this one we can say that Lewis acids are called electrophile. Electrophile in organic chemistry. Electrophile means Phile means attraction. Those substances which has attraction for electron, that's why which accepts electron pair, are called as electrophile. So this is the examples of acids. Now what are the examples of base? Molecules having one or more. Molecules having central atom with one or more lone pair of electrons. Example is H2O, which has 2 lone pairs of electrons, and NH3, which has 1 lone pair of electrons. Another is simple anions. Example is Cl negative, Cn negative. And And third one is Lewis base are called nucleophile in organic chemistry. So these are the three types of example in the Lewis base. And Lewis acid and Lewis base, when they combine, they form coordinate bond. We have learned this in chemical bonding. Example, BF3 and NH3. NH3 is electron pair donor. BF3 can accept that electron pair like this. Another is formed. This is called as the coordinate bond, where electron pair donor is a single atom, coordinate molecule. So, three very simple concepts: Arrhenius, Bronsted-Lowry, and the definition of acid, example, definition of base, example. So this is the initial part. Remember all this definition, remember example, because in question they will ask this particular substance act as acid or base according to Arrhenius, according to Bronsted-Lowry, they will give the option. So you should identify. So read it once, very simple part, you will understand it. Thank you for watching this video.